The James Webb Space Telescope has captured the world's imagination with its groundbreaking observations and insights into the cosmos. But what if this remarkable instrument has just unveiled evidence of extraterrestrial intelligence? The idea alone is electrifying. A signal from Proxima b, the closest exoplanet to Earth, that challenges our understanding of life in the universe. As you read this, astronomers, physicists, and data analysts are working around the clock to verify and interpret what might be the most extraordinary discovery in human history. Proxima b orbits Proxima Centauri, a red dwarf star located just 4.24 light-years away from us. While this distance might seem astronomical, it places Proxima b among our closest cosmic neighbors. Over the years, scientists have speculated about the potential habitability of this planet due to its location within the star's habitable zone. In simpler terms, Proxima b lies at the perfect distance from its star to allow liquid water, an essential ingredient for life, to exist on its surface. This tantalizing fact alone has made the planet a focus of intense scientific scrutiny. Now imagine the excitement when a faint but highly structured signal was detected during the James Webb Telescope's latest observation of the Proxima Centauri system. Unlike the random cosmic noise often picked up during space surveys, this signal exhibited patterns that defied natural explanation. It was coherent, repetitive, and seemed to follow a mathematical structure, a hallmark many experts associate with an artificial origin. For decades, humanity has searched the skies for signs of intelligent life. Projects like SETI, the search for extraterrestrial intelligence, have scanned countless star systems for radio signals that might indicate the presence of advanced civilizations. However, no discovery has come close to what the James Webb Telescope has reportedly detected. A signal so distinct that it has sparked debates across scientific communities worldwide. To understand the magnitude of this finding, we need to delve deeper into what makes Proxima be a prime candidate for harboring life. This exoplanet is roughly 1.3 times the mass of Earth, which suggests it could have a solid, rocky surface. Proxima b's orbit is relatively tight around its star, taking just 11.2 days to complete a revolution. While this might sound extreme compared to Earth's 365-day orbit, it's a common trait for planets orbiting red dwarf stars, which are cooler and less luminous than our Sun. One challenge with Proxima b is that it's tidally locked to its star. This means one side of the planet always faces Proxima Centauri, basking in perpetual daylight, while the other side remains in constant darkness. Scientists have debated whether this creates conditions too harsh for life to thrive. However, it's theorized that a terminator zone exists, a twilight region between the light and dark sides, where temperatures might be just right for liquid water and potentially life. The James Webb Telescope's advanced instruments have allowed scientists to gather unprecedented data about Proxima b's atmosphere. Recent spectrographic analyses hinted at the possible presence of water vapor, carbon dioxide, and even trace amounts of methane, a combination that could suggest biological activity. But while atmospheric composition is exciting, the newly detected signal is what's truly turning heads. What exactly is this signal, and why are scientists convinced it might be of alien origin? The signal is a narrowband transmission concentrated in a very specific frequency range. This is significant because natural sources, like stars or black holes, typically emit signals across a broad spectrum. Narrowband signals are often associated with artificial sources, such as communication technologies used by advanced civilizations. The signal also exhibits periodic variations, hinting at a potential message encoded within it. While decoding efforts are still in their infancy, some researchers have likened the pattern to binary code, a system of ones and zeros that we use in computer processing. If this is true, it suggests that whoever or whatever sent the signal intended it to be deciphered by a technologically capable species. Skeptics argue that the signal might still have a natural explanation, perhaps an unknown astrophysical phenomenon or interference from a human-made satellite. However, exhaustive analyses have so far ruled out these possibilities. The signal's origin has been pinpointed to the Proxima Centauri system, and no known natural processes account for its characteristics. If this discovery holds up to scrutiny, the implications are staggering. It would mean that humanity is no longer alone in the universe. But the next steps are equally crucial. Scientists must confirm the signal's authenticity through repeated observations. Additionally, efforts to respond to the signal could raise ethical questions. Should we attempt to make contact with an unknown intelligence, or would that invite risks we can't fully comprehend? In the next segment, we'll explore how scientists plan to analyze the signal further, what a potential reply could look like, and the cultural and philosophical impact of discovering alien life. Stay tuned as we continue unraveling the mystery of Proxima B's extraordinary signal. The process of verifying this groundbreaking signal is no small feat. The scientific community operates on a principle of rigorous skepticism, requiring reproducible evidence before making definitive claims. To confirm the authenticity of the signal, astronomers are conducting follow-up observations using multiple instruments, including Earth-based radio telescopes and other space-based observatories. This cross-validation ensures that the signal isn't a one-time anomaly or the result of technical interference. Additionally, teams are meticulously analyzing data to rule out every conceivable natural or man-made source. They're scrutinizing known astrophysical phenomena such as pulsars, quasars, and stellar flares, which can sometimes mimic artificial signals. Ground stations are also ensuring that terrestrial radio frequencies, like those from satellites or Earth-based technologies, aren't contaminating the observation. So far, all signs point to the signal originating from Proxima b. One of the most exciting aspects of this discovery is the potential for decoding the signal. If this transmission is indeed a message, it could contain information about its originators, their biology, culture, or even their technology. However, deciphering an extraterrestrial communication is a monumental challenge. Any advanced civilization may use a system of representation entirely alien to us, with no common linguistic or cultural references. Fortunately, mathematics and physics are considered universal languages. Patterns in the signal, such as repeating sequences or prime numbers, could serve as a Rosetta Stone. These would indicate that the sender understands the fundamental principles of the universe, creating a bridge between two vastly different forms of intelligence. Imagine if the signal encodes something as groundbreaking as instructions for building advanced technology or insights into their view of the cosmos. Yet, humanity must tread carefully. While the prospect of making contact with an advanced civilization is thrilling, it comes with potential risks. What if the signal is a deliberate invitation, bait even, designed to lure other civilizations into revealing themselves? Science fiction is replete with cautionary tales of first contact gone wrong, and some researchers advocate a listen-only approach for now. Stephen Hawking once warned about the dangers of advertising our presence to the cosmos. He likened the potential encounter to the arrival of Europeans in the Americas, a meeting that was disastrous for the indigenous populations. Similarly, we can't predict the intentions or technological capabilities of a civilization that has mastered interstellar communication. If they're hostile or indifferent to our survival, the consequences could be catastrophic. Nonetheless, the discovery of the signal has already sparked an intense philosophical and cultural dialogue on Earth. It forces humanity to confront profound questions about our place in the universe. Are we just one of countless intelligent species scattered across the cosmos? Or are we part of a rarer phenomenon? How should we redefine our identity as a species if we're no longer unique? Religious communities, too, are grappling with the implications of extraterrestrial life. For centuries, many belief systems have placed humanity at the center of creation. The confirmation of intelligent life beyond Earth would challenge these narratives, potentially reshaping spiritual frameworks and philosophies worldwide. On the other hand, the discovery could unite humanity in unprecedented ways. The realization that we share the universe with others might inspire a sense of global solidarity, prompting us to set aside our terrestrial differences. Cooperation between nations could become essential as we pool resources and expertise to study the signal and prepare for potential contact. Meanwhile, science fiction enthusiasts and futurists are speculating about the technological prowess of the civilization behind the signal. Proxima's proximity to its host star presents environmental challenges, such as intense stellar radiation. If life exists there, it must have adapted in extraordinary ways, perhaps through advanced biotechnology or artificial habitats. A civilization capable of sending interstellar signals might also have achieved remarkable feats, like harnessing the energy of their star, colonizing nearby systems, or developing faster-than-light travel. But for now, scientists are focused on immediate priorities, collecting more data and refining their models. They're particularly interested in the signal's time intervals and amplitude variations, which might hold clues to its encoding method. Advanced machine learning algorithms are being deployed to search for patterns that human analysts might overlook. If the signal is confirmed and its origin determined, the question of whether to respond will become inevitable. Any reply would need to be crafted with the utmost care, balancing the desire to communicate with the need to protect our species. The content, language, and intent of our message would require consensus across nations, cultures, and scientific disciplines. Could we send a simple introduction, perhaps something like Carl Sagan's famous Golden Record, which was launched aboard the Voyager spacecraft in 1977, a compilation of sounds, images, and messages representing life on Earth? Or should we remain silent, choosing instead to study the signal while keeping our presence concealed? Even without immediate contact, the discovery of this signal has already changed humanity. It's a reminder that the universe is vast, mysterious, and full of possibilities. Whether Proxima B harbors an intelligent civilization or not, the search for answers will undoubtedly propel science, philosophy, and culture into uncharted territories. As the James Webb Telescope continues its observations, the world watches with bated breath. What lies beyond our pale blue dot may not just reshape our understanding of the cosmos. It may redefine what it means to be human. Stay tuned as new revelations unfold, because this is only the beginning of a journey that could alter the course of history forever. In the wake of this potential breakthrough, numerous organizations and agencies worldwide have begun mobilizing their resources. NASA, the European Space Agency, ESA, and private entities like SpaceX are exploring how they might contribute to this monumental endeavor. The signal from Proxima has captured not just scientific interest but also public imagination, with social media, news outlets, and forums abuzz with theories, excitement, and speculation. Among the many possibilities discussed is the deployment of dedicated probes to the Proxima Centauri system. While current technology does not allow for travel at speeds necessary to reach the system within a human lifetime, projects like Breakthrough Starshot aim to change that. This initiative envisions sending lightweight, laser-propelled spacecraft to nearby stars, including Proxima Centauri. If successful, these probes could gather invaluable data about the Proxima system, providing insights into its planetary environments, including Proxima b. Closer to home, researchers are leveraging the James Webb Space Telescope's capabilities to focus further on Proxima b and its surroundings. Infrared observations are being refined to analyze surface compositions, atmospheric layers, and potential heat signatures that could indicate artificial structures. In parallel, other telescopes are being directed at the system to detect any secondary signals or phenomena that might corroborate the initial findings. Beyond the technical and scientific aspects, the public's engagement is also shaping how this discovery is perceived and approached. Crowdfunding campaigns have emerged to support independent research, and documentaries about Proxima b and the search for extraterrestrial life are being fast-tracked for production. Schools and universities are incorporating the discovery into their curricula, inspiring the next generation of scientists and engineers. The excitement has also led to an unprecedented surge in amateur astronomy. Enthusiasts with high-powered telescopes are training their lenses on the Proxima Centauri system, hoping to catch a glimpse or even contribute data to ongoing analyses. While the tools available to amateurs are limited compared to professional observatories, their passion and collective effort underscore the unifying power of a discovery that transcends borders and disciplines. As we stand on the precipice of potentially confirming the existence of intelligent extraterrestrial life, it's worth reflecting on how far we've come in our cosmic journey. From Galileo's first telescope to the groundbreaking discoveries of the Hubble Space Telescope, and now the James Webb Space Telescope, humanity has continually expanded its horizons, reaching deeper into the universe with each passing decade. Yet even as we look outward, this discovery compels us to look inward as well. What kind of civilization are we? What message would we send to the stars, and what would it say about us? The answers to these questions will not only shape our response to this signal, but also define our legacy as a species. In the end, the story of the James Webb Telescope detecting a potential alien signal from Proxima b is not just about the possibility of life elsewhere. It's about humanity's unyielding curiosity, our drive to explore, and our willingness to embrace the unknown. Whether this signal turns out to be the first greeting from an alien civilization or simply another piece of the cosmic puzzle, it has already achieved something profound. It has reminded us of the infinite possibilities that await in the universe. And so, as scientists continue their meticulous work, as philosophers debate the implications, and as the world watches with awe and wonder, one thing is clear. This moment marks the beginning of a new chapter in the human story, a chapter where the boundaries of possibility are pushed ever further, and the quest for knowledge leads us closer to understanding our place in the grand tapestry of the cosmos.